Great. So let's look at these concepts and their relation. Let's look at the differences among these: domain, codomain, image, range dependent variables. All right, good. So we are going to use the two diagrams to differentiate the two. We've already talked about domain, codomain, image, range, and dependent variable, but we have to use these diagrams to um, talk more about it. All right, good. Now let's look at the first diagram. When we say the domain, okay, we are looking at all set of what possible x what values, all set of possible x values. So all the values that you see, all the values that you see, the first set, okay, they are the domain. Okay, they are the domain. So in the question, if I ask you to write the domain of the first one, you are going to what? List all of them. So you are going to write 1. So let's say domain. I will use D to represent my domain. Okay, so if I say write the domain of example 1, you are going to write 1, 2, 3, and what? 4. That's good. That is what all set of possible values of x. Okay, and the domain that is also represent what they say x sort axis. Okay, if you draw the Cartesian plane, the x axis, all the values there, they also represent the domain. Okay, good. Now if I ask you to tell me what are the codomain, then you can also see that the codomain, they are the set of all possible values of y. They are the set of all possible values of y, and the codomain on the Cartesian plane also represent the values on the y axis. So let's take note of that. All right, great. So in this one, if I ask you to list the element of codomain, so this one I'm also using this as subscript C to represent what codomain. Okay, so I'm using that. I'm choosing that to represent that. It doesn't mean if you see DC or it doesn't mean that that is always what we used to represent. I am choosing DC and D as for domain and codomain. So if I ask you to list them, you are going to write 2, 4, 6, and what? 8. These are also what? The set of what? Domain. Good. Now let's look at image. When we say image also, we are also looking at what? All set of possible elements of the codomain or the y, which corresponds to elements in the domain. That is the image. We are talking about all set of what possible element in the codomain which corresponds to element in the domain. So for this, before we can say it is an image, we mean that they should have what corresponding domain. They should match with what a domain. So that is also what image. So most of the time we can say that the image is also what codomain. That is only when all the entire element in the codomain, each of them what has a corresponding element in the domain. Good. So if I say here, write the image. So I'm using I to represent my image. Here you are going to write 2, 4, 6, and 8 because all the elements you see here, all of them, you see that each of them has corresponding element. Okay, great. Now if I say range, so I'm using R to represent range. Now the same thing. So the range in some books you may see that we say that the range is the same as the image. Yes, so the range, they are also all set of possible values of y or codomain that corresponds to element in the domain. So once we have any element in the codomain which has or which relates to element in the domain, then this is also called what range. So we can say that the range is the same as what the image. Okay, all right, good. So if we have element in the Y which do not have any corresponding element in the domain, then we can say that that element is what is a range. Yes, so know the difference. Okay, so that when we say image or range, you see that we are talking about the same thing. So that one too will be the same. And looking at it, sometimes so we see the codomain are also what the range, because there are some codomains. For instance, the first example, you can see that there are all these elements have elements in the domain. So when the codomain, the entire codomain, each element in the codomain has corresponding element in the domain, then we see that codomain is also what the range or the image. Have you gotten that? That's good. Now let me use dependent variable. So I'm using the subscript v to represent dependent variable. When we say dependent variable, we are saying that they are elements that depend on what? The x-axis. So for dependent variable, we can say that it is also what? The codomain. It is also the codomain. Yes, so we are also talking about the entire codomain. Whatever is in the codomain, they are also called what? Dependent variable. Do you get it? So another name we can use for codomain is what? Dependent variable. So if I ask you to list element of dependent variable, you also write all the elements in the codomain. That's 4, 6, and 8. All right, great. Now let's look at example 2. So for example 2, as for the domain, we know that these are the first elements of the set. The two sets, the first ones always are the domain. So let's write the domain for the first one. So domain, still using D as my domain, is still what? 1, 2, 3, and what? 4. Good. Now let's look at the codomain. So when I say codomain, we are also talking about all the elements or all the possible values of Y, which are what? You can have 2, 4, 6, 8, 9, and 10. All these are what? Also with the codomain. Great. Now let's come back to the image. The image, which I use I to represent the image. As I previously said, for example 1, we are saying that the image, we are talking about elements in the codomain that have corresponding what? Element in the domain. So we are looking at all the elements that are the reflection. So most of the time, we always say that the image is a reflection of what? The element in the domain. Okay, it is a reflection. Okay, good. So if that is the case, then we can see that the image is also what? 2. Any element at all in the codomain which corresponds to an element in the domain is an image. Okay, so since 2 corresponds to 1, then it's an image. Let's look at other element. 4 is also corresponding to, so we can also have 4. What about 6? Yes, 6 also corresponds to 3. What about 8? 8 corresponds to 4. What about 9? 9 doesn't correspond to any element in the domain, so we don't add it. What about 10? 10 doesn't also correspond to an element, so we don't add the 10. So these are the image. Okay, now let's look at the range. So as I said previously, that the range is also the same as the image. Only element that corresponds to only element in the codomain that corresponds to element in the domain. So the same as the image. All right, the same as the image. Good. And when we say the dependent variable is the same as the codomain, so you list them all. Okay, good. So 10 and then here. Good. So if you look at example 2, you can see that 9 and 10 are not image or range. They are not image or range because they do not correspond to any element in the domain. Good. So these are the differences among these concepts, that is the range or the domain. Yes, the domain, the codomain, image, range, and dependent variable. Now, we are talking about dependent variable. The domain can also be called as what? If the codomain is dependent variable, then the domain is what? Independent variable. Another terms we can use for both domain and codomain is what? Input and output. So when we say input is what? The domain. The domain represents what? The input, and the codomain represents what? The output. Okay, whatever you put in gives you what? The output. All right, good. So these are the differences. Now, in our next video, we are going to look at what a mapping is. All right, we look at the rules of the various mapping, the types of mapping, and all that. Okay, so let's meet some other time. Thank you.